Hello everybody to Unit 6 of our NLP course. As you can see, this week we are using a different format, videos. Well, you all know why we have to switch to this format. About the next weeks, and if we stay with this format or maybe we switch to teleconferencing, yeah, we can discuss and see what is best and most feasible to do. Well, first of all, I wanted to say that I hope that you're all doing well, that you're healthy, and yes, keep it this way, wash your hands, and so on. Then the second point I wanted to mention is that, well, this is one of the first times that I'm doing videos like this. So I'm not like a YouTuber or something, so don't expect the videos to be technically brilliant. If you have any ideas on how to improve the quality of the videos, also from a technical point of view, other software to use, other kind of hardware to use which makes it better, I'm very happy to hear any feedback and suggestions about this. Yeah, so let's come to what we want to do this week. So this week in Unit 6 we have two major parts. Part 1 is to finish spaCy, which we have already started in the last unit. And then in the second part of the unit we want to have a look at PyTorch, which is a deep learning framework for Python, and we want to use it specifically for natural language processing, obviously. Yeah, so about the format of this lecture, I think it will be rather short YouTube videos, maybe 10 to 20 minutes, probably two videos, one for spaCy and one for PyTorch. And in those videos I will explain the most important and most basic concepts which we have inside of the IPython notebooks, which will be the basis for the unit. And I hope and expect that you have a thorough look at the notebooks, at the code inside, try to understand the code, and that you do the little exercises which help you to understand the code, which are also inside of the notebooks. In the last unit, as you might remember, hopefully, we discussed spaCy and we discussed the basic concepts of spaCy. For example, the NLP pipeline, which you feed a document and then it creates a doc object. And we also discussed, which was especially important for the homework, on how to use matchers to extract information from a text document. And the matcher, in contrast to regular expressions, it supports to do pattern matching not only in the text of the document, but also in the tokens and their token attributes which have been generated by spaCy. For example, to match attributes like part of speech tags, dependencies, identities, and so on during the matching process. Okay, we have now jumped to our notebook and to this point where we stopped in Unit 5. Like always, the IPython notebook and all the resources we are using, but in this unit it's mostly just two IPython notebooks, one for spaCy and one for PyTorch. They are available on GitHub under the URL which you already know. This notebook is actually still in Unit 4 directory, because we started with the notebook in Unit 4 and it's the notebook named Unit 4 to 5, but it also contains the first part of unit 6, so maybe I will change the name afterwards. But let's jump back to the notebook. So we finished last time with the matcher object, and the first thing which we have in this unit is the phrase matcher object, which is basically very similar to the matcher object, but it's optimized to match a large number of documents, so it's optimized for performance. So if you ever want to use spaCy in a production environment where performance is very important with a lot of documents, then you can use the phrase matcher, and how it's used you can see in the example here. Maybe more important, let's look at second thing as a second thing at the pre-processing pipeline in spaCy, because this is, well, the core of spaCy, this pipeline. So we already have seen it. It is when you feed a document to this function NLP, and then inside a couple of steps happen to extract different kinds of information, which is then saved to the doc object. And this doc object, it contains different steps which make different annotations, which are then saved into this document created by the NLP function. So these steps, they are the tokenizer, which is always done, it's necessary for all the other steps, and then there are other steps, predefined, usually part of speech tagging, parsing, and entity recognition. But these steps, they depend on the model which is used. So we have sometimes used this EANCore WebSM model, which is the small model, or we use the medium model also sometimes. And these models are basically packages of different pre-trained components, different models, which do different functionality. And as you can see on this little image here in the notebook, those models are packed into some kind of package, into directories, and there is a configuration file which defines which models a package provides to the user. We can print for a given loaded model which pipelines are in there. So here in this cell we print the pipeline names in cell number 3, and here in cell number 4 we print the pipeline functions or pipeline objects which are called by the model. What is now the interesting thing, which we did not discuss yet, is that you can create your own pipeline components and add them to the default pipeline. So if you add to your own components, then when you call the NLP function, then this steps will automatically be done. As we can see here in cell number 5, we define a function, compute length, which just computes the length of the document, so it's like a very simple function. And all those pipeline functions, they get as input the document and also return the document, because in the pipeline the document is put through the different pipeline components, so they always have the input document and they return maybe a modified document. Once we have the function, we can add the function to the pipeline with add pipe, and also tell the system where in the pipeline to add, with the keywords after or as first element in the pipeline, as last element in the pipeline. Okay, so this is the basic information about the pipelines. Let's do a little exercise, or well, you will do hopefully a little exercise just to create your simple pipeline functions. And in this exercise number 6, you should first write a function which checks if the document is in English language. For this you can use the doc_lang doc.lang underscore attribute, which is like part of the of this document object. So you should just check if the document is in English language or not. If the document is not in English, then print something like the wrong language, use another pipeline. And then secondly, please add a function to the pipeline which checks if the document contains two consecutive nouns. So if it contains some kind of noun phrase, like, I don't know, cooking device or something like that, two nouns in order. As you should already know, for this information you have to look at the part of speech tags and check if there are two part of speech tags in consecutive order. Okay, so please have a look at this exercise. Okay, let's suppose you have done it. When you have done the exercise, then you can have a look at the simple sample solution which I provided in the next cell, in cell number 3. They are not really in order, but yeah, you see it in the IPython notebook. So here is some example solution for the exercise 6. Okay, so after the exercise, let's continue with the custom pipeline components. In our previous exercise, in our previous function, we did not change the doc object, but usually that is the idea of pipeline components, to add some additional information into the doc objects. So we will have a look at how to do this in this next couple of cells. Oops, so this is setting custom attributes, properties and methods. First we look at attributes. spaCy calls this attribute extensions, because we extend the attributes of the doc object. We can extend either the doc object itself, so the full document, or we can add some attributes to specific tokens, or finally we can add some attribute to a span, so multiple consecutive tokens inside spaCy. So you should already know that the three main objects in spaCy which you work with are the document, the tokens in the document, or spans, which are used, for example, for named entities, which usually can include multiple consecutive documents. So to do this attribute extension, you first need to define for the type of object which you're working with which additional attribute you want to define. So this is done in cell number 22 here with the set extension method. After you have defined your additional attribute, you can have your function, same like above, and now you can put modifications to your document object into this function. For example, here we want to set the title of the document, and we do it with doc._.title is your new document title which you defined. spaCy has a convention that we use the underscore between the document and attribute so that it's clear that this is a user-defined attribute. In the same way, you can define token attributes or span attributes inside this function. And then finally, when the function is defined, you can add it to the pipeline, and it will be executed when you run the NLP object. Okay, then in cell 50 we just we try this new pipeline elements out and see that now we have those attributes in the document object after calling the NLP function on some text.